Hey, welcome back. So we haven't done a lot of Rust recently on the channel, and today we're going to change that and we're going to look at how you can get started with WebSockets using Tokio Tungstenite. Now, if you've been following this channel recently, you know that I've been building an AI agent network on WebSockets, a sort of virtual world for large language models and AI agents to go and explore and do interesting things. And that is what we're going to continue on in this journey. So we are going to build a WebSocket client using Tokio Tungstenite, which will provide a time service for our AI agent world. So before we build our Rust WebSocket client, the first thing we need to do is find some sort of public WebSocket server that we can use just to test everything is okay client side first. And then that works, we will then continue on to build our time bot. So to do that, I am gonna bring up Postman, and then I'm gonna select a WebSocket in Postman, and then I'm going to just put in my WebSocket address. Now, it turns out there's not a lot of WebSocket servers that are freely available for you to use, but there is one at WebSocket.events. In fact, specifically, it's WSS echo.websocket.events. And if you click connect on Postman, you see it's going to be connected. And then I can just type in something like hello world here, and then click send. And you see it's echoing back hello world. And before that, you see this sort of echo WebSocket event sponsored by LOB.com. So now that that works, I can go and create my Rust WebSocket client against that server. And then if everything works okay, then I can connect it up to my agent network later, and then I can build my time bot. So as you can see here, I've got a blank directory. So I'm just going to create myself a new application by typing in cargo new rust-websockets time, because ultimately I'm going to be creating a time bot. And as you will see, that it has scaffolded me up a Rust WebSockets time application. And if I just cd into that and now type in cargo run, it's going to build that, and then it's going to come back in with the standard hello world. So now if I open that up in Visual Studio Code, and we will just go to source main.rs, and then you can see there is the println hello world. So if we look at my cargo.toml, you will see at the moment it's a blank application. I've got no dependencies specified, but I am going to need a few packages as part of my application. Specifically, I'm going to need Tokio, which is the sort of asynchronous runtime framework for Rust, which allows us to do all our kind of async IO. And in fact, most web servers or any sort of socket-based services are built on top of Tokio. It is the sort of default standard for Rust. And in fact, if you check out my video on Tokio that I did maybe a year ago, it's a pretty detailed, in-depth explanation of how Tokio works, and you can use it to build TCP streams, etc. So I recommend you go check that out. We're also going to need a Tokio Tungstenite, which is a WebSocket library that sits on top of the Tokio framework. So somebody's built on top of that, as you'd expect. And then we need a couple of utility functions, such as futures util. So to add those packages, I'm going to type in cargo add, and I'm going to need Tokio. And specifically, I'm going to want full features. So I'm going to do -f and Tokio /full. I'm also going to need futures util, and I'll show you where I'm going to use that a little bit later. And I'm also going to need Tokio Tungstenite and specifically, I'm going to need the Tokio Tungstenite. And specifically, I'm going to need the Tokio Tungstenite /native TLS feature. And the reason I'm going to need that is in order to connect to that server, I need access to TLS. So remember it said WSS, that's a secure WebSocket service. And in order to access a secure WebSocket service, I need native TLS feature as part of Tokio Tungstenite. So I'm just going to hit return, and it will have added those features. And if you have a look in my dependencies, you see futures util, you see Tokio version, features full, and there's Tokio Tungstenite at native TLS. Okay, so now that we've done that, we're going to go into our main RS, and we're going to connect up to that WebSocket event server that we connected to earlier. So the first thing I need to do is specify the URL of the server we're going to connect to. So if you remember, that was WSS, and it was echo.websocket.events. And then for debug purposes, I'm just going to stick a sort of connecting to sort of message. So we'll just do println, and we'll say connecting to, and we'll put in our URL. So the next thing that we need to do is connect asynchronously to that WebSocket service. So to connect to that server, I need to use the connect_async method. And you can see that's part of the Tokio Tungstenite package. And specifically, I need to pass in the URL, and then I am going to await it. And if there's an error of some sort, I'm just going to come back with failed to connect. So specifically, connect async is going to return me a WebSocket stream. So I actually want to be able to have access to that later. So I am just going to assign this here and take that as a return value. Now, as you can see, there's a few squigglies here. Connect async cannot find the function. So if I click on quick fix here and select import, you will see it's coming from Tokio Tungstenite connect async. Now, there's a few other squigglies, as you can see here as well. Cannot find function connect async in this scope. And that is because I haven't specifically marked out my main function as async. So I'm just going to do this as mark that as async. And also because I'm using the Tokio framework, I am going to need to specify that this is now Tokio main. Now, if you check out my video on Tokio, that will go into a bit more details on how that works. Now that that seems to work, I just want to be able to see if I am connected to the network. So I'm just going to say connected to agent network. Cool. Now that that works, if I just do cargo run, you can see connecting to WSS echo WebSocket events, and then it's telling me it's connected. So it's actually made a successful connection. So that's pretty cool that we've had success connecting the server, but I need to go a little bit further because I want to be able to send and receive messages from that server. So what I will need to do is split up that WebSocket stream into a write and read stream. So to do that, I'm just going to say let, and we'll put mutable write here, mutable read. And then I'm going to call WS stream, and I'm going to call the split function on that. And what that essentially is going to do is take that WebSocket stream that we had there, and it's going to split it into the write and the read stream. Now that that's split, I can type in something like write.send, and then I want to be able to pass in a message. Now I haven't defined my message yet, so let's add in a message that I want to set. So we'll say let message equals, and we'll do message, and it's going to be text, and we will say something like aloha echo server, and we will just take the string literal that we've got and then turn it into this message text format. And that message text format is actually what the Tungstenite protocol needs to utilize. So if I just save here for a second, you're going to see there's a few squigglies appearing. So if I click on message there, and you will, we click on quick fix, and I just need to import Tokio Tungstenite message, and therefore that is going to work here. And then you also see on my split, you can see there's an issue there as well. So if I click on quick fix, and if I import futures util stream X. So remember earlier we added the futures util package, and that is so that we can access the split functionality. So we're in pretty good shape at the moment. We've defined our message, and as you saw before, we were in the middle of sending that message to the write stream. So far I've written write.send message. Now, because it is an asynchronous stream, I need to do an await on that. And then, of course, if there's any errors, I want to get a message. So I'll just say that is fail to send message. So now that I've done that, at this point, it should be sending the message. You see another red squiggly there. I'm just going to click on that, click on quick fix, and then you see import futures sync X. So we'll just add that in. And then the red squiggly goes, and our imports have been updated to include the write. So next thing I want to do is, now that I'm writing to the message, I'm going to receive responses back. And essentially, I want to be able to write that out to the console. So in order to be able to read messages, I need to access the read stream. So if I type in something like read next, for example, that is going to pull the next message off of the stream. And then I am going to need to await that. But what I now need to be able to do is take whatever comes out of that stream and then read it into a message. So I'm going to type in if let sum message equals read next await. So that means that if I do have a message, then I'm going to go into this if statement. If I don't have a message, then I'm going to skip past it. So that's good. I'm going to have a message, and we'll say let message equals message.expect, and we'll say failed to read the message. And now that I've got the message, I just want to write that out. So we'll put println, and we'll say received a message, and then we will just write out whatever that message was. And now if I run this, we should see received a message, echo WebSocket event sponsored by LOB.com. Now remember, when we accessed this on Postman, it sent a message as soon as we connected, and then it did the echo. So we just need to change this a little bit. So what I am going to do here is I'm going to take this read here, I'm going to run this before the write, and then that will show this. And now I'm going to read that one more time. So it's a little bit duplicated code, but it means I'm going to get that sort of sponsored message, and then I will get the echo there as well. And I will just put a bit of a println here as well to say sending message, and then we'll say what our message was. So in this case, it was MSG. And now if I rerun this, it should tell me what I'm sending. There we go. So connected, received a message, sponsored by LOB.com, sending message aloha, and received a message aloha echo web service. So I now have built my Rust WebSocket client. So now that that works, what we want to do is take this client and connect it into my AI agent network. Now, if you watch my other video on this, as I said, I am creating this sort of large language model WebSocket agent network where there's going to be lots of bots that run a network. It could be time bots, it could be math bots, it could be calculators, and that will be a place for large language models to go and explore and interact with different agents or different tools. So in that video, I actually created a agent server, and it was particularly called the game server, and therefore you could just connect up your WebSocket client to that and then query what other agents were on the network and then be able to send direct message to it. So what we will do now is we will start up that server, and we will connect up our Rust client to that. So if I just cd into my game server folder, you will see that has the bun project for that server. And if I type in bun run source index.tsx, that will fire up my WebSocket server on localhost 3000. That game server, that agent network server, is actually up on my GitHub, so you can just git clone that and then run that locally if you want. You will need to install bun first. You can check out the video on how to do that. So now that that's done, I should be able to take this and connect it up to my game server. So let's do that. So we'll come back into Visual Studio Code, and I'm going to change that from being WSS to WS. Because I'm running it locally and I'm not running secure sockets there. And then I will just run this as localhost 3000. Now, because my agent network doesn't send any messages when you connect, I'm just going to get rid of that initial connection that we have here so that we can then send a message directly to the server. So it's the exact same thing here. So we will send aloha echo server, and then we'll send the message and we should get a response. So now if I do a cargo run one more time, you can see here connecting to localhost 3000, connected to agent network, and then I'm sending a message aloha echo server, and then it receives a message aloha echo server as well. And the reason that works is that the bun server by default will do an echo if it doesn't recognize any of the command. Now, if I wanted to, I could change this from aloha echo server to who's connected. That's a specific command that that server understands. And then if I send that, you can see it returns connected bots. Now, at the moment, there's nothing coming back from this. That's because I haven't connected up any of my other bots. So we can do that really quickly. I will connect into some of my bun bots, and within there, I've got a time bot already built. So if I do a bun run index.ts, you're going to see it automatically creates a whole load of bots there. So you see time bot NYC, Unix bot, Morse time bot, binary bot, ASCII bot, assembly script compiler bot. Again, these bots are up on the my GitHub, but now those bots are connected to my server. And if you look at my bun server there for a second, you see bot registered, time bot, blah, 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 blah. In fact, earlier you can even see the connections we made there. So now if I run this again, cargo run, you can see who's connected, and now it's got a list of timebot, timebot, NYC, blah, blah, blah. Now, specifically, the timebot that we've created isn't listed as registered in this case. Actually, let's just kill that for a second. So we've shut down our bots. We will clear this. We'll run this one more time. We're back to having no connected bots. And what we will do now is we will actually connect up our bot, register as a bot onto this server. So to do that, rather than sending who's connected, I want to send a register as command. And to do that, I'm going to have to pass in the bot name as well. So I'm going to wrap this into a nice little format macro here. I'm going to stick in the bot name, and then I will say, change this from who's connected to register as. We'll just put some brackets here so that we can pass the bot name in here. I'm also going to have to set the bot name, so we'll say let bot name equals, and we'll set the bot name to rust time bot. And now, if I rerun my cargo run for a second, you can see it's now saying connected, send register as rust time bot. And now when I send the who's connected message, it says receive the message recent connected bots rust timebot. So now not only have I connected to my bun WebSocket server, I'm actually registered as a bot on the service. And actually, if I just run that one more time, and you see here, I'm registered as BE928 at the end. If I come in to my server for a second, you can see bot registered rust timebot BE928. There's the who's connected, sent the message, finds out who's the connected bots, and then obviously I've finished my connection here, so that timebot BE928 gets unregistered, and then the connection is closed. So now that that works, I actually want to be able to interact and be able to send my own messages from the command line. So I'm going to tidy up this a little bit more and then be able to receive messages. So I am going to keep the register piece here for a second. So what I'm going to do now is I'm just going to clean up this code a little bit. I'm going to take that sort of registration message and I'm just going to put it into its own method. So I am just going to add this register bot, which just does exactly what we did a second ago. And I'm going to remove this here now. And now we're just going to do that registration here within that method, rather than having all the code sprawling around a bit. So all I'm really doing with this register bot method is I'm passing in the right stream that we have created up here, and I'm passing in the name of the bot, which is rust timebot. And if you look here, the function is register bot, and I'm accepting in that split sync WebSocket stream, which is implementing async write when unpin. And then I'm also accepting in the bot name, and then we're doing exactly what we did before. There's a few extra imports that I need to do to support that, but it's all pretty good. It's just tidying up my code. So next thing I'm going to do is, rather than accepting one message and then quitting out, what I am now going to do is I'm going to get rid of this, and I'm going to add in a new function which is just going to handle any incoming messages. So it's going to be called handle incoming messages. It's going to take in the read stream that we split earlier. Again, it's got the same signature as we had before. And then I've got a while loop. And it's while let, and I'm going to take in a message. And I'm just going to be looping around doing a read.net. So it's exactly what we did earlier. And then I'm going to match the message, and as long as I get a message here, I'm just going to write out receive the message. And of course, if I get an error, I'm going to say error receiving message. So it's pretty much exactly what we did before. So now that I've done that, I can get rid of this single read, and I can replace it with my handle incoming messages. So now that I've replaced that single read with the while loop, any messages that come in, it's automatically going to kind of push out. And finally, the last thing I need to do is await the task so that the application doesn't quit out before we get a response. So now, if I just do a cargo run, you can see here I've now connected to WS localhost 3000, connected to agent network. I've sent the message who's connected, and then I've received a message back saying Rust timebot is connected. So we are looking in a pretty good shape at the moment. So in fact, if I wanted to, I could just change this back from my localhost 3000 and talk back to the public event server, and then rerun this one more time, and then you would see it connects to echo WebSocket events, connect to agent network, sends a message who's connected. I get the received message as sponsored by LOB.com, and then it's received a message register as Rust timebot, and then received a message who's connected. Remember, it's an echo bot, so any message I send, it's just going to return to me. So I sent registers Rust timebot, and I've sent who's connected, and it's just sent that back to me. So that's kind of cool. We're in a good shape. Now, next thing that we need to be able to do is be able to send messages ourselves to the underlying server. So to do that, rather than me manually sending in the who's connected blah 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 blah, what I'm going to do is change that so that I can just send it in from the CLI. So I will just have a new function called read and send messages. And then, as you can see there, all it's going to do is read in lines from the standard input. And then I'm just going to loop through the reader, read the lines, and then send the message across to the right stream there. So that is literally what it does. There's a couple of squiggly issues in there. So I'll just add an import statement here, which will now solve that. And then we have, all we're doing is importing async buff read ext. That is going to solve this. I can now get rid of this code here. And now I can just call my read and send messages function. And of course, like before, I've spawned this off into a separate task and then stored it here. And now I am just going to add that into my join. And now if I clear this, I run it one more time. You see I'm connected to agent network. I say who's connected. And then it's going to tell me, received a message, Rust timebot is connected. So we're looking pretty good. Now, if I were to restart up my earlier bots, so if we do a bun run index.ts, that is going to add in our timebots, Unix timebots, Morse bots, etc. And now if I type in who's connected one more time, I'm going to get a different list. So you see I've now got things like the binary timebot. And here, if I just take this, and say at this and say what's the time, that message is going to get directed to the binary time bot, and you'll see the received message, the current time in binary is 1000 whatever. And in fact, I can speak to any of the bots. So if I want to talk to let's say timebot UK, which you can imagine tells the time in the UK, so I'll say what's the time, it will give me the time in Europe, London, 9 o'clock. And of course, if I want to speak to timebot NYC, it's going to give me New York time. So at that time, what's the time? And then it's going to come back and say the current time in America, New York is 4 p.m. So what's happening underneath the hood there is when I type in at whatever, the game server that I'm running as my bun WebSocket server is recognizing the at whatever and takes that message and then directs it to the connected bot with that ID. So technically, if one of the other WebSocket server connections put in at whatever the Rust timebot thing is, then that would be able to respond if I handled those messages. And in fact, that's exactly what we're going to do now. We are now going to create a timebot so that we can connect into that WebSocket server, send a message to our Rust timebot, and then it's going to return the time as per there. So to do that, we will create a new piece of code. So to do that, we will cargo new Rust WebSockets timebot, which will be our brand new timebot. So for laziness, I'm just going to open up Visual Studio Code. For laziness, I'm going to take this blank cargo.toml. We're going to paste in the old one. I will just recall this timebot. So that's all of our dependencies. And then for the main.rs, I will just take the main rs from the previous project. We'll copy that. We will now come back into the previous timebot. We'll get rid of the hello world. Now, in this case, I don't need to read and send messages because it's just going to send responses. So we'll get rid of that. We will get rid of the read from command line bit here. I will get rid of my right handle on the join here. We'll stick with the name rusttimebot. In the old version, I'll maybe just change that from rusttimebot to Rust client so that we know the difference. So now we will have an interactive application, etc. So if I come into here and do a cargo run, you can see my application is now registered as rusttimebot. So that is good. And now what I want to be able to do is handle those incoming messages and send the time back to the sender. So I'm going to make a small change here. Very quickly, I'm just going to do an update. I'm going to change this from doing a while read next, and I'm going to just switch this into a loop and do a match next. Now it's exactly the same here, but I'm just changing it slightly because what I want to do here is parse this message and be able to extract out the sender ID and then store it in this sender ID variable. Once I've got that sender ID, then I am going to essentially get the current time. So you see current time, I'm going to get the message current time, and I'm just going to call local now format and get that here. So once I've got that format time, I'm then going to send the message to the sender. Yeah, so it's going to be at sender ID, what the current time is, which is going to come from local now format, which is my current time. So if I save that for a second, there's a few things I need to do. First one is I need to implement that parse message data. We'll just paste that in for a second. And again, it's really simple. All I'm going to do is look at the message data, and I'm going to find the pattern, which is comma message colon. And then I'm going to map that out here, and then I'm going to do a split to get the ID. And then as you see here, I'm going to get this kind of let here, which is going to tell me what the from is. And then I'm going to figure out what the sender is. Last thing I need to do is, as you see, I've got a red squiggly on local, which means I need some way of accessing the time. So I'm going to use the package chrono. So I'll just do a cargo add chrono. That's going to add that into my dependencies. Once that is done, I can come back into Visual Studio Code. So a lot happened there, but to recap for a second, we connect to the agent network. We're still splitting our streams as we did before. We do our register as we did before. Now I'm handling my incoming messages by calling it handle incoming messages. I don't need to handle CLI. That is gone. Now, obviously, I need to pass my read and my write stream because I'm going to be using both of them, because I'm going to be, when I get a message coming in, I'm going to be sending a response. So I need the read and the write channel there. And then, of course, I need to await my read handle here that comes back. So we're in a good space here. I'm handling my messages. I'm doing the loop that we did before. So we're just looping around. We're reading messages that come in from the WebSocket server. And then when I get a message, I'm going to parse that data to figure out what the sender ID is. Once I get the sender ID, I'm going to be going at whatever the sender ID is to send a message to them. And then I'm going to be responding with the current time, which is local now format in the current format. And again, I'm using the chrono package to get the local time. And then once I've got that formatted message, I'm putting that on my write stream. And I'm just taking that message that we formatted a second ago and write into the socket. That is essentially what is happening. And then that parse message data there is really just taking the incoming message and then finding out what the sender ID is. So with all that being good, if I now do a cargo run on this, my timebot is now up and running. If I do a cargo run on my original time client, that is connected to the agent network. So we're good. If I do a who's connected on my original client, you are going to see that Rust client is there, which is the one that we just had. But if I also pass in, you can see Rust timebot is there. Now, if I call at Rust timebot and say, what's the time? It is going to send that message across to my Rust timebot. There you go. So it's going to make the connection to this Rust timebot, and it comes back with the current time. So it is now part of my agent network.